Okay, so in number 9, it says, is the equation even or odd? Sketch the graph and verify using algebra. All right, so obviously the easiest way to determine even or odd is looking at the graph. So let's do that first. So we know that to be even, it has to have symmetry over the y-axis. Oopsie, let me do that. Over the y-axis. And to be odd, you have to have symmetry around the origin, 180 degrees. Now, if it's not even and it's not odd, so it's not symmetry over the y-axis and it doesn't have symmetry around the origin, then it has to be neither. Okay, so it would be neither if these don't apply. So now let's look at the graphs. So if I quickly graph this, x squared minus 5 is going to be 1, 2, 3, 4, 5, and it's going to go like this. Now, if you want to use your graphing calculator to graph these, you're more than welcome to. You should be able to graph them quickly because we're just looking at a sketch without, but I'll leave that up to you. So this graph has symmetry over the y-axis, so it's even. And this particular graph, 1, 2, 3, 1, 2, 3, 4, 5, we're going to have a graph that looks something like this. We don't have symmetry over the y-axis. It's not symmetry, doesn't have symmetry around the origin, so that we would say this is neither. And then in C, our graph looks like this: over 1, up 1, 2, 3, and then to the left 1, 1, 2, 3. So we have a graph that looks like this. All right, so if I put patty paper on this and traced it and rotated it 180 degrees, this has rotational symmetry around the origin, so we would say this is odd. And then when I look at this graph here, I have a graph that does this for the square root function, and this is not even, not odd, so it has to be neither. All right, so I think by far looking at the graph is the easiest way. So now the next thing that you want to do is, in order to determine even or odd, if the function is f of x equals x squared minus 5, or if we look at the opposite of f of x, so the opposite of f of x is what? Minus x squared plus 5. So when you look at the equation that we have, what matches? All right. So when you look at it, we get the same. So since they're the same equation, we would say that it is, we would say that it's even. Now, before we do that, I kind of forgot a step here, is we have to substitute in, so this would be even, this would be odd. And so what we have to do is we have to substitute in negative x. And so when you substitute negative x squared minus 5, when you substitute in the negative x equals, you get x squared, because negative times a negative is positive, minus 5. So we get the same thing, and because we get the same thing, it's even. All right, likewise, so to be even, it would have to be f of x equals the absolute value of x plus 3, absolute value minus 5. To be considered odd, it would have to be minus f of x, which would be what? Minus the absolute value of x plus 3, and then plus 5, because that would be the opposite of what this is. So now we plug in negative x to see what we get. And so we get the absolute value of negative x plus 3, minus 5. Now, we put a negative x in there, and so does it match either one of these situations? It doesn't match the, oopsie, I don't know why that came up. It doesn't match this, it doesn't match this, so then that's why we make it neither. All right, likewise, f of x equals 3 over x cubed, and then the minus of f of x would be negative 3x cubed. So then let's see what we get when we plug in negative x. So when we plug in negative x, we get 3 times negative x cubed equals, so then this would be minus 3x cubed. So when we plug in the negative x, we actually get the opposite. And so because we get the opposite, we say that it's odd. And so we've got f of x equals the square root of x, and then the opposite of f of x equals what? Minus the square root of x. And so when I input negative x in here to see if it's even or odd, I end up getting the square root of negative x. Now, does this match the top one? No. Does it match the bottom one? No. So because it doesn't match even or odd, we say that it's neither.